Hey friends, we are here again and we're looking at section 1.4, ordered pairs and relations. So it might look like in the next slide that we've got a whole lot of vocabulary, and we do have a lot of concepts we're going to talk about, but I would not write each of these words down. I want you to wait for a second. What I'm going to do is talk about some of them in a group, so I want you to just follow along with me. The first three terms refer to this figure that I'm about to draw. So coordinate system, coordinate plane, and Cartesian plane are all what you see here. You probably remember this. You've seen X and Y axes. You've talked about that. You've talked about the fact that over here, these are positive values for X. 1, 2, 3, 4. This way in the other direction, we have negative values for X. So this would be like -2, -4, thinking that's -1 and -2. These are positive values for Y. Here we go. That looks pretty neat, right? 1, 2, so forth. And this way it would be negative values for Y. So this is called the Cartesian plane for Rene Descartes. He's a mathematician, philosopher, and he was credited for organizing information this way, organizing numerical concepts in place. And when we talk about these things and organizing, what we really are talking about is ordered pairs. So let me break it down. So first of all, this thing here, all of this refers to this. So coordinate system, coordinate plane, and Cartesian plane all refers to the XY axis. So let's bring the next concept. Here's the Y axis. Y axis is always vertical, and the X axis is always horizontal. All right? The origin, and I'll highlight that in red. Let's see. Origin is this point here. Origin, when I talk about it, it's called the center or the 0, 0 point, because on the x-axis we're at 0 and on the y-axis we're at 0. Ordered pairs are what we find plotted on a Cartesian plane or a coordinate plane. So if I were to choose the point, let's say right here, can you tell me what the ordered pair associated with it would be? What would the ordered pair here be? Now when we write ordered pairs, we always write the x term first and the y term afterwards. So the ordered pair that we have here would be x, the x value or the value on the x-axis at this point would be 2. So I'm going to put a 2 here. And then the y value, 1, 2, 3, 4, would be here, 4. So I look at the point and I figure out where it is on the x-axis and where it is on the y-axis, and that creates an ordered pair, highlighted there in purple. An x-coordinate, in this case, I think a highlighter will be best in this case. I'm going to highlight my x-coordinate in green. So the x-coordinate is this term here, and my y-coordinate, which I'm highlighting in yellow, is this coordinate right here. All right? So that takes care of the vocabulary there. And I think all of this you've seen before, but hopefully you'll get comfortable with using the terms that we're talking about here. All right, so let's get started. Let's take a look at the other words that we need to talk about. So looking at the rest of our vocabulary, what we have is relation. A relation is a set of ordered pairs. So if I were to write down ordered pairs that referred to, let me think, what could I order that would be interesting? I don't know, the days of the week. If I order the days of the week from 1 to 7 and how much homework you get, that might be one thing. So, or how much homework you do, how many books you read. Let's do that. So on the first day, I read 2 books. On the second day, I read 2 books again. On the third day, I only read 1. On the fourth day, I read 0. Fifth day, I read 4. And the sixth day, I read 9. And the seventh day I read none. So here are a set of ordered pairs. They are ordered in a particular way, and they're pairs of numbers, and they can represent pretty much anything. I just made up this arbitrary example, but this is what ordered pairs look like. So I could say, here's the set of ordered pairs that represents the amount of books that I read on a particular day. All right, so the domain are all the x values of the ordered pairs in the relationship. So the domain in this case, my domain, and I could write it as my domain for the relationship that I just created up in the upper part here is 1, 2, 3, 4, 5, 6, and 7, because those are the first or the x values that I've used. And then the range refers to the y values. So the y values of my ordered pair were 0, 1. I used 2 a couple of times. I don't need to write that several times. I also use 0 a few times. 4 and 9. So I don't have to write over and over again when I'm talking about either my domain or my range if there's repeating numbers, if there are repeating numbers. So my domain is listed here and my range is listed here. The next thing we want to look at is how to graph ordered pairs. And we kind of alluded to that when we looked at the Cartesian plane, when we looked at the coordinate plane. Let's try to graph these. So we have our xy axis here, and I like to label it. It helps me remember which one is which. And I know that this is positive, this is positive, this is negative, this is negative. And what I'm going to do is kind of take a look at first my x terms to see how far to the right and how far to the left I need to go. When I look at this, I see that I got to go all the way up to +5 and I've got to go back to -4. So I'm going to number by ones, and what I do in one direction, I've got to do in the other direction. So 1, 2, 3, 4, and 5. And here I'm going to move back, equal spaces, and do the same thing, -1, -2. I know that looks like a 7. -3, -4, and -5, just for general purposes, okay? Let's see if we can fix that a little bit. So now, it's less like a 7. All right, so now I need to write or figure out how to label the y-axis. And I look again and I see how high up do I go? I go up to a +4, and the lowest I go is 0. So 0 is there, 1, 2, 3, and 4. When you are labeling axes, you must be consistent on the axis. So notice I numbered by ones across the x-axis. If I found it more convenient, I could have numbered by 2s along the y-axis, but what I do to one side of the x-axis, I need to do to the other side of the x-axis. What I do to the top portion of the y-axis, I need to do to the bottom. So in terms of spacing and the way I count, and you always want to start at 0 if possible, and we'll talk about that other stuff later. All right, so here we go. Let's go ahead and get to graphing. So if I graph this first point 24, I go to the right 2, and I go up to +4, and there's the point 24. If I want to graph the point 50, I'm going to start at 5, and it says go to 0. Well, that means don't go up or down, you just stay right there. So that's the point 50. The point 04 tells me that I go to 0 on the x-axis and I go up to 4 on the y-axis. And the final point that I have is point -4, +1. So I need to go to -4 on the x-axis and to +1 on the y-axis, or go up to +1. So I'm looking at +1 from the y-axis. All right? Okay. So, I mean, that really is it. And I know you guys have done that before. All right. This next problem requires a graph. Let me put that up. Okay, that's better. So now that we have the graph, we can label the points A, B, and C on the coordinate plane. So now we see that A is here. Let's label it with its ordered pair. What ordered pair is being represented by the point A here? And we realize we go over 2 down to -4. So this point is 2, -4. When I come up to, let's do B first. When I come up to B, the ordered pair that is associated here, I go to my x term first. I get -3. And notice we don't move off the x-axis, which means we stay at 0. So this is -3, 0. On the y-axis, it tells me that if I started at the origin, at the center, I didn't move left or right to get to the x-coordinate. So that means that my x-coordinate is 0 and my y-coordinate will be 1, 2, 3, 4. And that's how you label. Let's take a look at the next example. This next example shows that we can write relations as tables. And so it's pretty simple. What we're going to do is make a table where we have x. Let me try that again. Okay, that's better. You're going to make a table where you have x and y, and you're going to write down each of the points according to their x and y coordinates. So I can write 2, 3, 0, 4, 1, 6, 3, do I have space? 3, 5. Let me extend that a little bit. And 6, 2. So I've written this relation as a table. The next thing they asked me to do is to determine the domain and determine the range. So in this case, the domain, right? We remember that the domain refers to the x values. It's already set up there for us. So the domain, I'm going to use a capital D there, is equal to the set of 2, well, let me write them in order, 0, 1, 2, 3, and 6. I'll write this a little bit better. Hold on. Nope, that's not an eraser. So we're going to do, sorry about that, 0, 1, 2, and 6 for the set that's called the domain. And my set that's called the range, I'm going to write out the word range in this case. The set that's called the range is going to be the set of these numbers over here. So that's 2, 3, 4, 5, and 6. And that's it. All right, let's take a look. So a relation as a graph. So we saw that we can write a relation as a table. We saw we can write relations as ordered pairs. Now we're going to look at writing it as a graph, or graphing the information we have. A seahorse swims at a rate of 5 feet per hour. Make a table where the x-coordinate represents the hours and the y-coordinate represents the number of feet for 1, 2, and 4 hours. Then we're going to graph the ordered pairs on a graph. I think we can do that all here. So let's see what's going on. Let me get a graph here. Or rather, let's start off with a table. So we know we're going to be dealing with x and y, and we're told that the x-coordinate represents hours. So I'm going to just put hours over here to help me remember. And the y-coordinate refers to the number of feet that the seahorse swims. So now that we want to know the number of feet for 1, 2, and 4 hours. So I'm going to put 1, 2, and 4 right here. And I'm going to go back to the problem and see if I can figure out how to do this. Seahorse swims at a rate of 5 feet per hour. That's 5 feet for every 1 hour. So I know the answer to the first one here is going to be 5. So if 2 hours go by, it should be 10. Notice, I guess I'm multiplying, right? 4 hours, that's the next one, it should be 20. So after 4 hours, the seahorse has gone 20 feet. All right, so now we're going to graph the ordered pair and describe the graph. So when I graph this situation, I'm not going to take my time like before. I'm going to just go ahead and do it. I'm only using part of the coordinate axis, and I'll tell you why. Because there's no negative numbers in this situation. So I'm just looking at the positive x-axis and the positive y-axis. In a way, we can't really conceptually, in this case, think of negative time, nor can we think of negative movement, like, oh, he went negative 4 feet. So I'm going to just do it this way, all right? Stay with. All right, so here's what we got. We have 1 and then 5. So, oh, I have to go all the way up to 20. I can count by ones here. 1, 2, 3, 4, 5, and so on. But I can't count by ones here. 1, 2, 3, 4, 5, 6, 7. 7's the highest, and I need to get to 20. What can I do? This is a great time to use your multiplication skills. If I need to get to 20 or even a little bit above, I'm going to count by something that will encompass these. I'm going to count by 3s. 3, why? Because I say 1, 2, 3, 4, 5, 6, 7, and 7 times 3 is 21, so that means I'm going to get, no, yeah, maybe, okay, we'll see. We'll talk about that more in class. 3, 6, 9, 12, 15, 18, 21. I made it, okay? So now I have I have enough values on my y-axis to encompass the range values that I need to do. See, using vocabulary. Okay, we're going to get this done. So after 1 hour, pardon me, that seahorse travels 5 hours, so I'm going to be just underneath the 6. After 2 hours, that seahorse travels 10 feet, which is going to be slightly above the 9. And after 4 hours, that seahorse travels 20 feet, which is there. So what I'm seeing is that, so it says describe the, graph the ordered pairs and describe the graph. What do you guys think? What's going on here? To me, it looks rather like it's linear. It looks like a linear equation. It looks like a linear representation. I feel like if you thought line, I think that sounds good. And so the description is that, it looks like these points are falling in a line. And if you thought that, you're right. All right, guys, I think that is enough for us today. I can't wait to see you. I look forward to working with you. Let me know if there's any questions, and we'll talk soon. Bye-bye.